So good afternoon, everyone. Thank you for joining us for the second day of our annual forum. For those of you who don't know me, my name is Catherine Wilson. I'm the manager of the Mayor's Megawatt Challenge, a program that's been working with municipalities since 2003 to reduce the energy use in their own facilities. I'd like to take this opportunity to thank our sponsors, Simcoe Refrigeration and Enbridge Gas, who have been critical to helping us and our municipalities achieve our objectives. We're meeting on a virtual platform, so we want to begin by acknowledging the Indigenous peoples of all the lands we're on today, wherever we call home. We acknowledge the ancestral and unceded territory of the Inuit, Métis, and First Nations people. I acknowledge that I'm speaking from the traditional land of the Huron-Wendat, Haudenosaunee, Anishinaabe, and the Mississaugas of the Credit River. At our opening session last week, we shared the results of the roadmap to net zero ice rinks, a pilot which took a cohort approach to developing individual roadmaps for 9 municipal ice rinks to get their buildings to net zero carbon emissions over time. We shared the best practices and lessons learned throughout the pilot, so you can apply the learnings to your own portfolio of ice rinks. In terms of overall findings, we concluded that net zero carbon emissions are achievable and financially feasible in municipal ice rinks, but it does require an all-encompassing evaluation of measures, employing life cycle costing, which accounts for operations and maintenance costs, and aligns the timing of measures with capital renewal or planned investments over time. We have shared the recordings of these sessions with everyone who registered, and we'll also be sharing them on our website. Recordings of previous webinars and forums can also be found on our website. So as we have mentioned often, on-site renewables are a critical component in the roadmap to net zero carbon buildings. Today, we'll be exploring the technical and financial suitability of on-site renewables at reducing carbon emissions in municipal facilities. Following the opening remarks, we'll sit down with OEC, the town of Oakville, and Geosource Energy to discuss the role of geo-exchange in decarbonizing municipal portfolios. Sean McCoggan, Chief Strategy and Growth Officer at OEC, will speak to the value of geo-exchange and the uniquely exciting opportunity it presents in the municipal space. Dave Cano, Energy Solutions Manager at the town of Oakville, will then walk through a case study featuring the geo-exchange system at the Oakville Trafalgar Community Center. Steve Schaefer from AMP Energy will then speak to some practical considerations of solar PV installations, including what all municipalities should know before undertaking a solar PV project. Then Gil Amdursky from the Toronto and Region Conservation will speak to the Sustainable Technologies Evaluation Program, including the Renewable Energy Initiative and some other projects of interest to municipalities. Concerning logistics, if you have any questions related to technology or non-content questions, please enter them in the chat box. If you have questions related to content, please use the Q&A. Depending on the nature of the question, some questions will be addressed live and others in a Q&A session following each presentation. As always, we'll circulate a Q&A document with the proceedings after the event. So before we dive right in, we have some folks on the line who may be unfamiliar with the Climate Challenge Network and the Mayor's Megawatt Challenge program. So here it is in a nutshell. So the Mayor's Megawatt Challenge is a program of the Climate Challenge Network, a not-for-profit with the goal of rapidly reducing building-related emissions in multiple building sectors. In this case, it's a collaborative effort between municipalities, industry, academia, and utility companies, all working together towards a common goal. A recent net zero ice rinks cohort project shows how this works in practice. And it was so successful that we plan to replicate this type of project going forward. The Mayor's Megawatt Challenge program is based around 4 components. First, the identification of savings potential and high potential buildings using available building data. Second, determination of best practices using an evidence-based approach and supported by real savings at the meter. Third, networking between municipalities, including facility staff and other organizations. And last, but certainly not least, recognizing and celebrating success. Our content is driven by members, and we always aim to make our presentations credible, practical, and relatable by providing non-biased information from real people on the ground. So we always aim to highlight successes and address issues and challenges using the experience of real building managers and operators focusing on collective solutions from diverse perspectives and experiences, pulling together knowledge, resources, and experience and ask tough questions. So on that note, I will now hand things over to Darren Hagen from Geosource, who'll be introducing and moderating today's session on geo-exchange. Take it away, Darren.
Awesome. Thank you so much. I'm just sharing my screen now. Here we go. So good afternoon, everyone. Thank you so much for joining us today. We'd also like to thank the entire Mayor's Megawatt Challenge team for convening this event and inviting us to participate. My name is Darren Hagen. I'm the Manager of Development at Geosource Energy, and I'll be moderating this session. Today, we're very excited to discuss the role of geo-exchange in achieving net zero performance in municipal buildings. So we have a very large challenge ahead of us. Climate change is real and it's happening now. Municipalities across the country are tasked with both reducing their emissions as well as protecting their communities from the inevitable climate impacts. The municipalities are often under-resourced. They continue to take real steps towards creating more livable, safe, and healthier communities. So that's why it's such a privilege to sit down today with OEC in the town of Oakville to learn more about how they're using geo-exchange to meet their goals. So for those of you who may not be familiar with geo-exchange, at a high level, it's a technology that allows us to move heat between buildings and the ground. So it's a highly efficient method of electrified heating and cooling, and it ultimately reduces the building's overall carbon footprint. So our discussion today isn't going to delve into the details of how geo-exchange systems work, but the Mayor's Megawatt Challenge has hosted some introductory webinars earlier this year that dig into the specific. So the links for those should already be in the chat box. Now, I am very excited to introduce today's experts. Our first speaker today is Sean McCoggan, the Chief Growth and Strategy Officer at OEC. So his current focus is to advance and augment OEC's strategy, evolve the organization's capabilities, and drive sustainable growth. OEC has owned and operated geo-exchange systems for nearly a decade, and today Sean will be speaking to how and why those systems are excellent investments. Our second speaker today is Dave Cano. Dave is the Energy Solutions Manager at the town of Oakville, where he leads the corporation's energy and carbon management portfolios. So he's currently developing the long-term carbon management strategy for the town, which includes energy conservation measures, deep energy retrofits, and renewable energy generation. So Dave will be walking us through a case study today focused on the geo-exchange system at the Oakville Trafalgar Community Center. Last but not least, we have my colleague, Adam Aleitza, the Director of Engineering and Development at Geosource Energy. Adam leads the development of geothermal utility initiatives, including collaboration and coordination with clients, technical and financial feasibility, and business case proposal development. Adam won't be presenting today as we'd like to maintain a focus on the municipal side of things. He will, however, be acting as our geo-exchange subject matter expert, and he will be present for the Q&A portion. So without further ado, I will turn it over to Sean.
Good morning or good afternoon. Thank you, Darren. Does everybody see my picture come through? Yeah, excellent. Well, as Darren mentioned, I am the Chief Strategy and Growth Officer at OEC. I'll just spend a moment on OEC for those that haven't heard of us. OEC is a energy and infrastructure services provider servicing customers in Canada. We have a significant presence in Ontario and are headquartered in Oakville. My goal today is to leave you curious and excited about the growing role of geo-exchange systems in Ontario. At OEC, part of who we are is our renewable energy geo-exchange business that you just heard about, where we have been advancing the use of geo-exchange systems for quite some time. My focus today in my comments is really about the impacts geo-exchange can have, the growth that we're seeing in the industry currently, and I'm also going to touch on the simplicity of the solution and OEC's operational experiences. So to begin, we just heard from Darren that we all follow in the news the continued global efforts to target net zero goals, and we're doing so with new technologies, offsets, carbon reductions, and other items over the long term. So when we look at this at OEC, we're taking a diversified approach to this challenge as many different types of energy and technologies will contribute to the energy transition. Fundamentally, we believe that creating greener energy buildings with a low carbon geo-exchange solution is an important pathway in helping us achieve our carbon reduction goals. We've built and operated geo-exchange systems with many more underway. And recently, we took the extra step in our journey and partnered with Geosource Energy, Canada's premier geothermal construction specialist. Together, we have more than 30 years of combined experience and over 350 geothermal projects designed and delivered. When we sit back together with our broad capabilities and Geosource's deep technical expertise, we're working now to deliver a turnkey geo-exchange solution to those customers, to our customers. So let me pivot a little bit, and given this webinar and this discussion, I think if you're curious about geo-exchange, what I'm trying to convey, and my colleague after me will as well, it really is a very simple solution. As Darren mentioned earlier, it's a solution that harnesses the thermal temperature or energy from the ground beneath us and utilizes it to heat and cool buildings. The footprint is not invasive. It's actually quite small for the system, including the wells underneath the building. And as mentioned in the introduction today, you're going to hear a lot more about a recently constructed community center in Oakville, which is a shining new example of community energy in action. OEC was very proud to be involved in this project, where we're certainly in from the beginning, right through the design, the build, construction, and ongoing maintenance of the project. For those of you looking at my virtual background, this is actually a photo that we took the other day of the operations center in that community center that Dave will be speaking to. And this shows where the geo-exchange system comes into the building and then is distributed. I thought I would also touch on some things you might find interesting in terms of the broader industry, the building industry, and what we're seeing. Certainly from our vantage point, we continue to see this solution being adopted more often, whether that's in Southern Ontario, other parts of Canada. There are literally now thousands of projects installed and under development, meaning essentially we are moving much further with adoption to a more broad, full implementation. I think it's rather exciting to see the decisions being made today to install geo, whether that be in campuses, airports, hospitals, condominiums, or community centers, that's happening. Again, these solutions are real commitments by communities such as yourselves that also result in upfront capital reductions and ongoing operational cost savings to help achieve net zero targets. That's a little bit about the why for geo-exchange. Some of you may also be thinking about the how. So I'll just touch on that. The nature of heating and cooling can seem daunting, but it really isn't. Geo-exchange is a very straightforward system, which you'll hear more about. I know being unfamiliar with a solution can raise questions. In this case, common questions may be the concern of once an installation is in a building, how would it be operated? Is it going to require a new skill set? And the reality of the solution of the technology is it doesn't require any of those. Not only facility staff can oversee this and not overwhelmed with complexity, but we, organizations such as ourselves and Geosource, are there to support. In fact, our model is designed in a way that we provide dedicated support to a facility with a very long-term commitment measured in decades over the life of the building. What I like about today's forum, among many things, is it provides a chance to share a real case study that illustrates exactly what you're getting when adopting a geo-exchange facility. And I think this webinar helps demonstrate visible leadership by these communities on behalf of all of your taxpayers. So with that, I'd like to thank you for having me today. I'm certainly encouraged by the proactive leadership that the Mayor's Megawatt Challenge is showing in getting the message out there and educating decision makers on the solution. My goal again today is to leave you feeling curious about the possibilities that geo-exchange can bring. And next, I'd like to welcome my colleague, Dave Cano, from the town of Oakville. Dave has a wealth of experience in this area, and he will be sharing with us his exciting overview of the project and facility, practical takeaways from his experience implementing this system, as well as environmental benefits and key learnings. So once again, thank you very much.
Thank you, Sean. Good afternoon, everyone. I'm very happy to be here today to talk about our experience with geo-exchange. Before I delve into the facility we want to showcase today, I did want to share with you why the town of Oakville is going through this path. Not unlike many of our peer municipalities in Ontario and throughout Canada, Oakville adopted greenhouse gas emissions reduction targets for 2050, which they stand at an 80% reduction compared to our 2013 baseline. Back in 2019, the town also joined other municipalities and organizations around the world by declaring a climate emergency, doubling down on our commitment to reduce our carbon emissions. So with that being said, let me introduce you to our facility, the Oakville Trafalgar Community Center, or OTCC. The state-of-the-art 53,000 square feet community center officially opened its doors in 2020 and is home to a variety of amenities, including a 25-meter lap pool, a therapeutic pool with accompanying change rooms, a fitness center with walking track, gymnasium, various meeting rooms, and a cafe. With a focus on providing services to our community year-round, and knowing that we needed to tackle carbon emissions and energy use from a holistic perspective, we integrated several aspects that could help us reduce the impact of its operations, with the largest by far being a geo-exchange system. Working collaboratively with OEC and Geosource, we integrated a 64 borehole system with heat pumps that could provide the entire heating and cooling needs of the facility year-round. The facility does have 2 large water heaters, natural gas fired, that complement domestic hot water usage in the facility. They also have the ability to supplement temperatures in the geo-exchange loop if the ground system is not supplying enough energy for heating. However, these 2 water heaters are only for auxiliary purposes and do not consume a large amount of natural gas on an annual basis. I'm sure everyone's wondering, well, how much does it cost and how has this helped us from a financial perspective? I'll give you some numbers to think about. But in order to do this, I would like to compare the OTCC facility with another one of our community centers, just to put it in perspective. With a similar profile to OTCC, this other community center, let's refer to it as Community Center 2, has a 25-meter lap pool, a therapeutic pool, fitness center, gymnasium, community rooms, an older adult center, and a branch of the Oakville Public Library. Community Center 2 has a total footprint of 69,000 square feet, or roughly 30% more than OTCC. From a carbon perspective, in the past 12 months, OTCC used 1.4 million kilowatt hours of electricity and 2,328 cubic meters of natural gas. Together, they amount for 46 tons of carbon dioxide equivalent, out of which only 4 of those are associated with natural gas, or less than 10% of the total carbon footprint of the facility. To compare, Community Center 2 during the same period used 1.5 million kilowatt hours of electricity, a very similar profile to OTCC, but instead used 260,000 cubic meters of natural gas, which is roughly 100 times more than OTCC. From a carbon perspective, Community Center 2 generated 536 tons of carbon dioxide equivalent, out of which 490 were associated with natural gas. This means OTCC can help us achieve savings of almost 99% compared to Community Center 2, which goes from 4 to 500 tons of carbon dioxide equivalent, bringing it very near to a net zero standard. Total capital costs of the project were a bit over $1 million, plus additional funding required to integrate the geo-exchange system into the facility. Based on the numbers that I provided previously and including the cost of the carbon tax, which I think we all know will reach $170 per ton by 2030, yields us an operational energy cost for OTCC of $240,000 annually. On the other hand, Community Center 2 has an operational energy cost of $397 annually, which accounts for a difference of $157,000 per year. Using these numbers, we get a simple payback of 7 years for the system alone. Now, I do have to acknowledge that Community Center 2 is 30% larger. However, the main systems that would use up most of the natural gas use are very similar in nature, and thus make the comparison a bit more straightforward, as most of the savings come from natural gas and the related carbon emissions. An additional benefit for the geo-exchange system is that it is pretty low maintenance. It has been operational since December of 2019, and it has not required any major maintenance performed on it. We do foresee exchanging some of the components within the next 20 years, but for the most part, the system will not require any major maintenance for the foreseeable future. Before we go to the next slide, I did want to talk about an unforeseen benefit that we have heard from our community. Since the community center opened its doors, both staff and community members enjoying our facilities have told us that the air within the facility feels cleaner. And even when you go into the pool area, you do not get that chlorinated, stuffy sensation that you get in other pools. It would seem that the indoor air quality at this facility benefits from the geo-exchange system, and it's something we might want to corroborate in the future. Next slide, please. To end this conversation, I wanted to share some lessons learned, as the installation of the large system did not come without its hiccups. And I acknowledge that most of us in the public sector have concerns about integrating more non-traditional systems at our facilities. I do hope these lessons learned help you answer some of the questions you may have around geo-exchange as a long-term solution. First, if you are thinking of using geo-exchange as a main heating and cooling system, integrate it into the building design from the beginning. We made the decision to integrate geo-exchange after the initial design was completed, which meant additional costs were incurred to change the design of the systems to be able to connect to the geo-exchange field. The second, make sure everyone on site knows exactly where the system is going and have accurate drawings shared with your contractor and subcontractors, basically everyone that's working on site. An anecdote, when installing light poles in the parking lot before the project was completed, one of the subcontractors hit one of the boreholes and we had a leak which caused the system to go down. It wasn't a major event, but Geosource was able to come on site quickly to repair the system. It could have been worse if the subcontractor had hit more than one borehole or hit any other of the critical components of the system. Third, think of this solution as a whole from an energy management perspective. Although it allows us to greatly reduce carbon emissions, it does use more electricity to run the heat pumps and auxiliary equipment. What we considered at the town was to complement energy use in the facility through a solar PV system. We are in the process of installing a 250 kilowatt DC system with an additional 250 kilowatts to be installed in the near future in an adjacent parking garage. When implemented in its entirety, this 500 kilowatt system would provide enough electricity to power the system in its entirety and then some, providing us a truly net zero energy and very low carbon heating and cooling facility. And finally, and this is probably the most important lesson that we've learned through this project, you need to find a good partner to do the work with. This is the second geo-exchange field we have installed at one of our facilities, yet the first one did not provide us the great work that we were hoping from. This caused us some serious doubts on our side to engage again with this kind of technology for OTCC. However, working alongside OEC and Geosource, it really helped us clear out some of those doubts, as it is evident that they have experience in the field and the results really speak for themselves. I will now hand back the presentation back to Darren before we conclude this session and go to question and answers. Thank you.
Wonderful. Thanks so much, Dave. I'd say both you and Sean have given us quite a bit to think about. Now I'm just looking through our Q&A here. I noticed Adam McMillan, he had asked a question regarding capital reductions. Adam Elitza, you had made a response in the Q&A, but I wonder if maybe you wanted to follow it up verbally to maybe elaborate a little bit more.
Hey, Darren. Confirm you can hear me okay?
Confirming.
Great. Yeah, I think in general, the question was in relation to the capital cost comparison of a geothermal system versus conventional. I think the narrative that was provided in the response, pretty concise, but ultimately the capital cost borne by the municipality or the facilities that is managing that asset will be a function of which project delivery model you leverage. But commonly, if we're saying when implementing a geothermal system, what you're able to typically avoid from a capital perspective is the need to build a boiler plant or a cooling tower plant. With conventional systems and boiler plants typically being heat generation and cooling tower plants for cooling processes, getting rid of heat. if you're able to leverage a business model similar to that of what OAC speaks to, the actual cost of the ground heat exchanger is funded by the provider, in an example where OAC would be at the table. So it'd be no additional capital cost for the ground loop, potential upside and avoided capital cost to the facilities team in that particular setting.
Okay, and taking a look at some more of the questions here, Amanda Martin has asked, what is the typical industry lifespan for a geothermal heat pump? Maybe Adam, if you could speak to the ground portion, and then I think maybe Dave, you can speak to, what we would experience on the mechanical side within the building. That'd be great. So Adam, starting with you.
Yeah. So the ground side, I think it's very common in our industry with the material manufacturers and providers, the piping sector for geothermal heat exchangers to provide a 50-year limited warranty on their infrastructure. I think independent reviews have been done by establishments like the Plastic Pipes Institute, which claims that the actual effective life expectancy of that infrastructure could be 100 years plus. Full disclosure, the material has been around for, I believe, 70 years and been in application with no issues. So we're hopeful that 100 years plus is attainable for this infrastructure.
And if I could speak to the building side, I think the industry lifespan is very similar to traditional heat pumps for commercial and institutional installations. I would say our expectancy is to have those pumps in for 15 to 20 years, at which time we would have to look at a bit more of a major replacement of equipment. However, when we're talking about those 15 to 20 years, the system has already paid back by itself.
Right, makes sense. I'm seeing another question here regarding geothermal soil degradation and its effect on surrounding area. I wonder if maybe, Adam, you could speak to whether or not we've ever seen geothermal soil degradation.
Yeah, for sure. I can speak to this, and maybe we can follow up with a little bit more detail if there's interest. So when we talk about soil degradation in the context of geothermal systems, it's commonly referred to as thermal fouling. Thermal fouling is an effect that can be realized on a number of ground source systems when there is heavy imbalances present in facilities' heating and cooling requirements. So, for example, if you have a facility that requires much more cooling annually than heating, what can happen is that field temperature can migrate over time. I mean, a way this is managed at Geosource as design builders in the market and with OEC is we implement as a standard a very comprehensive data acquisition package on all the geothermal systems that are implemented, which basically means we're monitoring and collecting actual performance data of the system. And we're able to dynamically work hand in hand with our customers to ensure that systems remain balanced to avoid the possibility of soil degradation over time. So I'll leave that there. If there's an interest to unpack further, happy to discuss.
Absolutely. Feel free to follow up again in the Q&A if it wasn't adequately answered by Adam. I'm seeing another question here. So there's increasing regulation regarding ground source water protection. So have we experienced, oh, it just moved here, sorry. Have you experienced any issues with permitting or approval to dig or drill vertical bore field? Adam, this will be another one likely for you as Geosource is active on the ground installation side.
Yeah, thanks, Darren. I think that's, so in Ontario, there is environmental compliance approval and regulation of installation of geothermal systems, particularly in the drilling sector. So providers in this market, for example, like Geosource, being the leader in the construction and implementation space in this sector, we have environmental compliance approval that allows us to drill in Ontario and provide this service. That being said, there are some municipalities and townships that have municipal water tied into groundwater aquifers. And there is regulation around where we can implement vertical loops within those catchment areas. So again, close coordination with cities, towns, and townships in reviewing permit approvals of buildings and assessing what's being implemented is critical. And that would catch the typical viability of geo being implemented or allowed in those regulated areas.
And I think maybe if I could build on that a little bit, Geosource, we specialize in the closed loop vertical installation. I know that a number of municipalities that have a little bit more concern with source water protection, I think the Kitchener-Waterloo area is a great example of that. They're a little bit more open to open loop systems, and that's largely because the number of penetrations through the aquifer is significantly reduced. There's one source and one output pipe, and rather than maybe 50 or 60 boreholes penetrating the aquifer. So yeah, I think to Adam's point, discussing with the municipality in question or discussing with your staff is really important. But there are other alternatives for geothermal or geo-exchange. And we specialize in the vertical closed loop, but there are a number of alternatives as well.
Yeah, that's a great statement there. And also horizontal, not to interject, I apologize, but there are different means of closed and open loop systems, and that very, very great dialogue to add in there. Absolutely.
Mm-hmm. I'm seeing Jillian, you'd like to answer Amanda's question live about the heat pumps. Did you want to add a comment there?
No.
Okay, sorry, I just noticed that it popped up. Awesome. Yeah, Amanda, I saw that you followed up as well. We'd love to contact you. Yeah, feel free to contact. Obviously, Dave is there. Our emails are up here on the screen, but Geosource as well, in terms of if you have any technical questions. Ultimately, we want to be here to support all of you. So I think maybe taking a bit of a broader look, Geosource, we get a lot of questions about long-term operations and maintenance, of these systems. I wonder, Dave, would you be able to speak to what happens on a day-to-day basis with these systems and maybe how they differ, in broad strokes from conventional systems?
Sure. I have to say, really, there's not much happening on a day-to-day basis. I think we just let the system work. We just monitor to our BAS to make sure that the conditions within the facility are appropriate. And then I don't think we've really had any big requirements to the changes to the system in itself. I do recall when they were completing construction that some of the workers were complaining that we're feeling too much heat because the system was providing too much heat to the building. So some adjustments to the heat pumps were performed at that time, but really we haven't heard any complaints from the community members or our staff working at the facility regarding air quality within the facility. So I would say on a day-to-day basis, it's really just runs on itself, and we just have to troubleshoot whenever we find any issues, which hasn't really been the case so far.
Right. And I think maybe as well, thinking more from a portfolio perspective, maybe Shauna, it'd be great to get your insights as well. If we say a geo-exchange system, has been implemented, what can customers of that utility system come to expect from OEC in terms of ongoing operations and maintenance in supporting, facility staff?
Yeah, great question. I think we try from a customer's expectations point of view to make it very light touch, given the simplicity of the system. We measure our commitment in terms of decades. Like, we are there to support this system. We provide dedicated monitoring around the clock. We have access to remotely as well as on site. We work with building owners by assigning a point of contact to make that customer journey not only from the outset but through life cycle easier. And so there's somebody to call and deal with anything should anything come up. We also obviously do a lot of work just over life cycle planning, whether that be maintenance planning that would occur down the road if anything should need to be replaced. So those are some of the things that we offer and put together to make that customer service aspect really seamless and light touch for the building owner.
I think judging from your response as well as Dave's response, it doesn't really seem like there is too much difficulty that goes into either the day-to-days or even the long-term operations. It's more of just being intentional and planning ahead and just making sure that everything has kind of been prepared ahead of time and everybody knows what's going on.
Yeah, I think that's fair to say. I think these systems run well and they run on their own, and they deliver what's required. So it's a matter of making sure that just continues.
Yeah. And I think maybe to round out the panel on this question or this theme, Adam, do you think you could speak to how in the design and construction stages, how that can play a role in the long-term operations and maintenance of these?
Thanks, Darren. Yeah, I think that the way we like to discuss the successful implementation of geothermal systems is there's really three pillars to success in any of these types of assets being folded into building programs. The first obviously being thoughtful design. Geothermal systems require due diligence in energy modeling and detailed design to ensure systems are sized for conditions of today, but also valuing in our perspectives of where the future is going from a climate migration standpoint. So effective design is critical in implementation of these systems. Obviously, the next biggest pillar for success is leveraging the SMEs, subject matter experts with the track record of delivering assets, on time and on budget to specification. Very critical. A lot of this infrastructure lives below ground. You want to ensure that it's being implemented as specified in your detailed design exercise. And then the biggest pillar of success, I think, that ties the front end execution of these systems in is the active and mindful management of the assets. We spoke a little bit to this. Sean has mentioned it. I've briefed on it before in the soil degradation question. But having actual data available of how these systems are performing is critical. We live in a data-driven society. Data is very valuable, and it's no different. It's actually exemplified for this type of technology. Being able to monitor it, collect it, trend it long term gives you, the granularity and the foresight to actively and mindfully manage these systems and ensure that they're performing the same way on year one as they do year 30 and beyond.
Yeah, absolutely. I think, we've talked a little bit about, the long-term performance of these systems. They last a long time. We regularly get questions about, with climate impacts, we're expecting to see, warmer summers and perhaps even warmer winters as well. I wonder about, Adam, you speak a little bit to the minimizing the risk on the design side. And Dave, you had mentioned, thinking of it holistically, thinking of the building holistically. And I think it sounds interesting in terms of making sure that when the system is designed, it's brought in a number of opportunities, some heat source and sink components. I guess, Adam, could you speak to now, what type of advice you would give to municipal staff in terms of what to look for when designing their system, making sure that it has the flexibility to have that operational, to maximize the operational benefits long term?
Yeah, sure, Darren. I think it's a great question. Ultimately, it's a bit of a crystal ball challenge that many design teams are trying to wrap their head around today of where is the climate going? How does the energy use intensities of facilities change over time? There's a lot of suggestion that in high performance building facilities, cooling becomes a more dominant load, and how does that get exacerbated with climate migration? But I think Darren's point is it's a pretty simple. You can implement some pretty simple measures to safeguard the long-term performance of these systems, and it's about being flexible. Ultimately, the challenge comes down to how we manage heat. So if we have an asset that's sized for today's characteristics of what buildings need, leaving in the flexible provisions for heat inlets and heat outlets into a geothermal system to manage that balance. So that balance piece is key. A way we can do that, and we see this in high-performance buildings, is adding in other heat sinks into a loop to provide a way to leverage waste heat and provide that annual balance. Things like domestic hot water production, snow melt are great applications, or even maybe a small fluid cooler that could be implemented at year 30 to, in the winter offload some waste heat that's not leveraged throughout the heating and cooling process of typical loads in the facility. So it's all about flexibility. Leave an inlet and leave an outlet for heat to flow. Heat can come from various forms of technologies, and ultimately that heat can be leveraged for other loads in facilities as well.
Wonderful. I'm just checking to see, does anybody have any further questions for our panelists at this time?
Hi, Darren. I'm going to jump in with a question here.
Sure.
So municipalities are tackled with the monumental task of achieving net zero across the entire municipal portfolio by 2050 or sometimes sooner. Is there a particular place that would be good to start in terms of a building portfolio? Is there certain building types that may be more suitable to this type of technology? Building types that maybe aren't as suitable? Is there sort of like general rules of thumb, or is it very building specific?
Right. Dave, I wonder, if you're handling the energy outlook for the town of Oakville, maybe you can speak to your experience in the town. I know that there's a number of geo-exchange systems within the town's portfolio.
We currently have two systems, this one at the community center, and we have another one at our transit facility. However, the one at transit is the one that's not really working as well. And it was a smaller system. It only served a smaller portion of the facility. However, from our experience, what we've seen is that if we're able to make this system work in a community center that has such a big load in terms of a big thermal load, then we can extend this type of geo-exchange system pretty much to any location that we want. I think what you need to do is make sure that when you're working with your building design or when you're thinking about doing a retrofit, you have to involve a specialist in the conversations very early on in the table so that you can consider what kind of changes in your mechanical systems will be required to really maximize the benefit of a geo-exchange system, and also to identify other ways to supplement either the electrical or thermal loads of the facility, or to make use of the waste heat that just comes naturally from some of those processes.
Absolutely. I wonder, Adam, do you have any thoughts in terms of the theory side, or from a design side?
Yeah, thanks, Darren. Just I guess briefly, again, when you think about ground source geothermal applications like we're talking about in this session, you have to think about it as a heat movement and storage technology. So this technology works best in a clear-cut way when we have facilities that require heating and cooling, and can be implemented to manage really any load requirement, really. But the need for heating and cooling to provide balance to these vessels is an important element. So any commercial like usage, industrial applications for have heating and cooling, or community centers like we're discussing today, geothermal could be a great fit for all of those.
Absolutely. And I think maybe looking forward to, the ultimate 2050 goals or even sooner for net zero, we talk a lot about new builds and planning ahead, but I wonder, Dave or Adam or Sean, do you have any thoughts in terms of how best to approach retrofitting existing buildings? Is geo-exchange an option for those buildings? Are there methods maybe on the construction side? Adam, maybe you can speak to that as well, in terms of, optimizing the implementation of geo-exchange for retrofits.
I can speak to that first, I guess, Darren, if you'd like.
Sure.
Yeah, retrofits are always inherently challenging for any technology. What's critical, and I would speak to what Dave had suggested, is engaging SMEs in the space, involving them in conversations early to kind of frame out a project's goals and rank what types of technologies are and means and methods are available to address your goals in a retrofit application. But I think geothermal specifically, in retrofit applications, again, just to stress the need for facilities that have heating and cooling to be able to be provided by that vessel. That balance characteristics is critical for closed loop, typically vertical geothermal systems. And means and methods that I think Geosource brings to market, as an example, are some very compact and innovative drilling and implementation approaches. Angle drilling as one we're implementing on a retrofit right now, actually, which allows us to get a lot of geothermal capacity with very little at-grade real estate to work with. So those types of innovations in construction would be critical. Some other concepts would be in building or below building drilling with smaller modular rigs. Less common, but a possibility as well to get that capacity on site.
Great, thanks, Adam.
I could probably just build on what Adam was commenting on there.
Absolutely.
An example also in Oakville is OEC's head office. So that was a retrofit. The building was constructed late 80s, 90s, and it's a 2-floor, 3-floor facility, commercial real estate. And we undertook a retrofit to Geo probably about 5-6 years ago. And so the well pad where the vertical loops was inserted was underneath the parking lot. So we had access to drilling fairly easily. And it was put in. I think what Adam mentioned in terms of obviously balancing, making sure that is all appropriately designed is important, But from a success story, we've had it running ever since, and it's been fantastic.
That's great to hear. And I guess, you know, would you expect, or have you experienced operational savings as a result? You know, obviously there's the capital cost of it, but in terms of, you know, reducing those electricity costs and the natural gas requirements, have you seen some benefits from it?
We have folks have monitored that, both in terms of the savings on the commodity of energy side, and then obviously looking at the carbon reduction side as well. Yeah, that's obviously why we went on to do it, and it's worked out quite well.
Awesome, it's great to hear that. And Dave, I see you've turned on your video.
Yeah,
I
I just
thoughts.
wanted to mention we haven't undergone a process to determine feasibility for geo-exchange for retrofits in our facilities, but that's something we're starting to think about. So maybe something we will start doing next year. But we are considering geo-exchange as a feasible alternative for heating and cooling. Now, I do know that in most of our facilities we already use heat pumps. So that helps with building the case for connecting to a geo-exchange field. That's usually one of the largest issues you have on how can you connect a geo-exchange field to your facility. So we're already ahead of the curve on that one, but we still need to do some work around understanding how can our older facilities benefit from this type of technology into the future.
Great, thanks so much, Dave. And I think just remaining cognizant of time, I don't want to take up too much of our slots. So I think, you know, unless any of our panelists or any of our audience members or anyone from the Mayor's Megawatt Challenge team has any further questions for our team, I'm happy to sign off. Thank you very much to our audience members, to the Mayor's Megawatt Challenge team, to our speakers. Ultimately, please reach out to myself, to any of our speakers. You know, our emails are up on the screen. You know, or if you're interested in perhaps a facility tour, I know that the OEC or Town of Oakville team would be happy to facilitate. But ultimately, you know, we implore you to have the confidence to act. You know, this technology is proven and it's been around for a long time. And as our experts have commented on, it is very successful in achieving its goals. And so this is going to be a big part of how the energy transition happens. And ultimately, I think at this point, the cost of inaction is really far outstripping that of the alternative. Thank you so much.
Thank you so much, Darren, and thank you so much as well to Dave and Sean and Adam for your fantastic presentations and insights to share with everybody. You've really highlighted here how geo-exchange can make sense, and providing some of those lessons learned from the Oakville Trafalgar Community Center, I think will be really useful in helping our other municipalities who are considering this technology.